Hi, Patrick. I'm sorry. I'm sure you told us before, but I'm trying to remember which company you are with. Can you guys hear me?
Hi, Yogesh.
Hey, Simple, how are you?
Hi. Yes, fine, thank you. How are you also?
Doing well. It's Friday. Charles, are you with us for the first time?
Yes, I'm here for the first time from Cisco, working on RAS features for our memory and ASICs.
Welcome.
Thank you.
Let me know if you have any trouble finding relevant links. Did you join Group IO? I saw someone from Cisco. I'm trying to remember the name. Did you join Group IO and you have access to the Google Drive and everything?
Yes, I did. Yeah, so still kind of learning and getting my experience here, getting started. But yeah, thanks for sharing this.
No problem. Very welcome. Glad to have you.
Hi, Yogesh.
Good to have you too. Welcome.
Yeah, hi. Before the meeting gets started, I saw you just gave me access to the shared drive, but I'm not able to. I wanted to upload my the sort of the PCIe kernel AER doc that I've been working on with Drew to it, but I don't have permissions.
Let me check again.
Thanks.
I think I'm not a master of Google Drive permissions. Just just go with the flow, I guess. But yeah, I can check for yours. Hey, Jyotika, Meeta, Shubhda, welcome y'all.
Hi, good afternoon.
Hey, everyone.
I guess that by this time schools have started everywhere pretty much. Isn't that right? Kids, schools and stuff.
Yes.
You can tell by the way people are driving.
Yeah, driving duty started. Or started to wake up on time in the morning.
More disciplined.
Yeah.
Or not.
Hey, Mark,
Hi, Yogesh.
is it hot enough yet, or you wanted to notch it up a little bit more?
Hey, it's Houston. It's August. It's hot.
Yeah. And Victor, who are you with? I don't know. Your name doesn't show company name. Actually,
yeah, I'm independent. Just here to listen.
Okay, good. Yeah, so generally everyone, if you could add your company name followed by your name on the Zoom, it helps everyone to know. So 5 minutes over. I think we should start taking opens at this time. So, John, I have your request. I'll look into that. Make sure that you have the full access that you need to upload documents.
Great, thanks.
The deadline to upload your first draft of any presentations that might have been accepted for Global Summit is on Monday. It was very tight this time, so I don't know. Very few submissions got accepted for hardware management track. It's only half a day.
Was that a general announcement or pertaining to my request?
Just a general announcement. I I just wanted to remind folks if they have any submission accepted, it's due Monday.
Gotcha.
Yeah, I think if there are no other opens, then we can either wait for Anil to drive or start diving into the in-band document. So for those who are joining for the first time or newish, we are working on a contribution. We already made a contribution, which is OCP hardware fault management infrastructure requirements. The first version of that document focused on out-of-band hardware fault management. It did a lot of foundational work defining error types that needs to be handled or reported by the data center hardware, defining the various data fleet deployment models, and also defined various agents that that do typically play a role. And now we're working on the next version of the document, which incorporates in-band error handling. And that is being driven by Anil, who just joined.
Hello. Sorry, back-to-back meetings
I know.
typically overrun.
Yeah, GPU is bringing down the head node. Tell them.
Yep.
They need a better RAS.
we spent a lot more time in discussing, should we have this discussion in GPU section or the next section, the next meeting? Because it goes, there's so many of the system level views, right? There or requirements. It's very hard to partition because they're interrelated.
Yeah, it's not even good to partition beyond. I mean, it's good to compartmentalize things, but not hard partition in that sense.
Right. So we were struggling with that, but good thing is, with Drew and Carlos and all, we have kind of weed through those issues. And I mean, there's still work need to be done, but we are making good progress. Good.
So you want to, if there are no other opens, unless you have one and Drew have one, unless you have any, just feel free to dive right in. We have a lot of activity in the document. I'm glad to see that it's really taking shape pretty fast. So start on that.
All right. Let me go ahead and open it. I mean, while I'm doing it, yeah, anybody has any other questions, comments? Okay, I'm going to share my screen.
So meanwhile, Anil, I saw that you started with some of the descriptions. I modified them a little bit and added more content. So
sure.
When we review.
Yeah. Is Vilas on the call today?
Okay. Did he join the previous call? Oh, okay. I saw a note from him on the call that he's not going to join today. So I don't know if he's going to join this one either.
Okay, so then let's come to Subhada, the edits you did. Why don't you drive then? Discussion. Let's go to yours first, and then.
Before you start, Anil, one quick announcement I forgot to make, but I wanted to wait for the quorum to build up. I think next week is the Friday before long weekend. We would like to cancel that meeting. That should be okay with everyone, I think.
30th, right?
Yeah.
Yeah.
Yep. Okay.
I'm okay. Anybody else?
Yeah.
Anybody
Let's
has
go
any
ahead.
concern? Okay.
Sounds good.
No, I
Give
think
me
we
some
should
time
still
to-
have it.
We should have a Houston edition. What are you going to do outside, right? It's still hot.
Maybe one more thing I want to kind of level set here now that I know for the GPU requirements spec, we're really trying very hard to complete it before the global summit. For this requirement, I'm proposing that let's not drive too hard because there's first of all, I don't think because there's quite a bit of work need to be done here after finishing
this
this
is
exercise.
Yeah, no, Anil, I
So-
totally on that with you, and I like to hear from other people. But I think this is more convoluted. There's a lot of pieces here, and I think we should do good work and more complete work, more implementable work than trying to rush it to the
Yeah.
finish line.
Right. And having said that, I do want to drive some milestone, which is I'm saying toward the end of the year, like the November timeframe, is where we should have a cleaned up copy to for wider review. Wider
Yeah.
audience review.
That sounds
think
good to
that-
me.
That
Hey.
goal we should make.
And before we get started, I just John sent me the PCIe thing that you asked for, and I just realized it and didn't send it back out. So John, thank you for that. I'm so sorry I didn't respond. And Anil, this is the PCIe driver stuff that we were talking about last week. So I will stuff that in the Google Drive and send a link during this meeting to folks to take a look.
And let's go through Subhada's edits, and if we finish that in time and we still have time, then maybe we should, because John is here, right? We can at least give John last 10, 15
that'd be
minutes.
awesome. Yeah, that'd be great. Thank you.
Yeah. So, Shubhada, you want to kind of drive the discussion?
Sure, yeah.
Do you want to share, or should I continue sharing?
I have it open, so I can share too. Then
Yeah,
I
let
can
me-
just drive it as I go. Yeah.
Perfect.
Oh, in Zoom, it's tricky. How do I do this? Okay. Do you see your screen?
Yep.
Oh, but I lost the other screen. I don't know where it is, but it's fine.
Yeah, I can see it.
Okay.
Others can see?
Yeah, I was just looking for my mute unmute button, but that screen is lost somewhere else. But it's fine. I just need this one. Okay, so we stopped somewhere here where we talked about the kernel or up to the RAS API and the actions, right? And we were talking about the kernel layer.
Is it possible to zoom in just a little?
Oh, sure. If I know how to do this. Oh, here. Okay, so the RAS API is where we stopped last. The kernel layer handles the errors and the events based on the notification and logging mechanism that is standardized. So this was relating to the current mechanisms, right? We are not changing any of that in band handling mode. All of those could go underneath the layer which is going to provide the standardized interface. And similarly, device drivers expose the error data to the IMA in a standardized format and satisfying the requirement of the software scalability for the hyperscaler infrastructure. This is related to this particular connection here. So the device drivers provide standardized information to the IMA and could also have the RAS action interface, right? So drivers and the plugins are at the same level.
So Shubhada, sorry to interrupt you. 1 second. The kernel handles the errors and event based on the notification logging mechanism that is standardized. I'm not sure which standard you're referring to here.
This one was, okay, let's see here, right? So kernel, so these are standardized mechanisms like, MCA, AER, DPC. So that's, I actually added that below in one of the description here, right? So it would include something like MCA,
Okay.
AER, and
Yeah, I got it.
APER.
I think it's better to just spell it out. Basically, what he's saying is that kernel receives the signals using existing methods. I'm not sure we call standard because there are vendors like machine check architecture is a.
It's it's
I'm
specific
not
to
sure.
x86. Yeah.
It's yeah.
Oh yeah, it is architectural, which means it is specific to certain architectures, right?
Right, existing
So,
methodologies, right? Just such like MCA.
Okay.
Existing industry-wide method, something like that, right?
The thing is, for OS vendors to implement something, right? They need some kind of specification that is you can call it standardized or architectural, right? Because it is open and all other, all kinds of kernels are relying on that to write a standardized code. Like, you have STM to do the MC architecture and so on. So
I think maybe we want to call that because there are two known CPU architecture, right? x86 and ARM, right? So maybe we can call that or something like that. Like kernel handles errors even based on notification logging mechanism provided by industry standard CPU implementations.
Yeah, we can call it industry standard.
There's also, I don't know if you guys are tied into the RISC-V spec as well. That is in the works by RISC-V International.
Oh, okay. Yeah, then let's be aware of that.
It's the RARI spec. I don't know if it published. I think I saw a version. I mean, it's on the website, but I don't know if it's already published or it's a draft. But it's called the RARI spec.
Right. So in industry standard CPU. So industry standard is good enough. In the bracket, you can call example x86, ARM, RISC. I think these are three architectures we know of so far, right? Just to provide the clear context, right?
Okay. Standards. Even PCI AER is part of that, right? Or do you mean only the CPU architectures? It's not really CPU architecture.
You can call you can call PCI spec also, PCI, Now output from the kernel layer, by the way, maybe I'm missing something. Kernel doesn't provide CPER format. The CPER format that is implemented today is actually the firmware reports to kernel in the CPER format.
Mm-hmm. Actually, maybe we could call it APEI, and then that can
which is also reporting to the kernel, right? Kernel output, to best of my knowledge, there is no standard output, right?
Yeah.
sysfs, maybe we can call it counters, right? And then dmessage, and then RAS daemon. I mean, these are, and then maybe some proprietary implementation, right? That's all I am aware of.
Right? I mean, it is well. So if you think about GHES, right, like
Windows VIA.
Right.
So so VIA actually the input coming to the VIA handler is CPR, but how VIA reports it, right? Who's the consumer of VIA? I think maybe you're right, in the Windows environment, they do, actually, I don't even know whether they report in CPR format there or just consolidate into some sort of a, counters and their Windows specific format, let's put it this way. So, but I think the point is very, very, very relevant though, right? The output is required, right? So I think what we want to call that out is that we need the kernel output, or so maybe kernel, not kernel directly, but using some daemon or driver, output to be CPR formatted data.
Yeah, because I mean, so far that is the one which can be consumed to either send it to sysfs or whatever other softwares that may want it, right? So that's the intent here, that the standardized error output comes to the kernel layer, and from there it can be actually exposed in any other ways, right? If it is exposed in sysfs, it's just going to extract some of the data from the CPR and then push it somewhere.
Right. So, output from the kernel layer is required to be, or it is required,
or the CPR. Basically, I want to say that content of CPR is then dispersed wherever, right? That's
yes.
Well,
that is the intent.
Isn't this just like the out of band? I mean, the out of band, you send CPR and then we route it to some tool that analyzes it and decides we're going to take action. It's the same thing on this side, right? We get CPR, it gets percolated up to some analysis tool that decides what to do about the error, right?
Yeah, but that doesn't exist today.
Right. But I guess
what we're saying, calling it out at kernel layer is what the problem is, right? That's what looks like. I mean, you're pointing out that it may not be just like kernel layer. That
no, it is required. I think the way I'm reading this sentence is that it already exists today, but that's not true. What we want to say is we require that. It doesn't exist today. Now, maybe kernel layer or software layer, we can make it generic software layer, because we don't want to mandate that kernel we need some further and very major surgery into kernel, right? Because kernel does provide the trace.
Actually, we already mentioned that RAS API is the one which is going to give the standardized CPR format, right? So I think instead of talking about kernel layer, it is the RAS API.
What we can say here is, Shubhada, that the kernel then propagates the error information to rest of the software stack using I don't know what you call trace. What is the Linux terminology there? John, I think you know better, right?
Well, for RAS daemon, it's trace points, right? But I think you said for the EDAC driver, it's sysfs, or essentially like you're correct in that there's no like standard way to do it in the kernel, and I guess it's a little bit of foreshadowing, but the sort of the work that Drew and I had been working on previously on the sort of kernel support, involves sort of that in-band memory agent doing the sort of the standardization, if you will, to compile that information to CPRs and then make it easily digestible to upstream tools.
Right. So we would just want to call that out here, that the kernel processes the CPR records, or basically error records.
So I'm just wondering why we should say anything about the kernel, because that kind of sounds like we're either requiring the kernel to do something, or we are already expecting it happens. Whereas I don't think this document or standard is about the kernel. All we need to do is say that the in-band management agent expects the information in a certain way, and now how the layers below it, which could be the device driver, the kernel does it, is whether they need a intermediate sandwich layer like RAS plugin or not. That's just dependent on the implementation.
Yeah, so the reason we probably want to make that clearly is because in the block diagram we are showing. So idea of this verbiage here is to describe each and every box and the arrows, right? So how do you want to describe this kernel box, right? There's input here and there's output here. So we just want to call out what it is today.
Yeah, but we're not defining the input between the kernel and the RAS plugin, are we?
We're not. We just want to call it out.
Yeah, this CPER is the one which is it needs to be surfaced to the RAS API layer, right? So whether kernel participates or not is not something that we really need to specify. So I agree with Meeta. What she's saying is, I mean, why specify what role kernel is playing in this path? Because it may or may not play any role.
Yeah, we just want to call it out what it is today. That's it. We're not asking any new requirement. Now, John will come back and say, hey, we are making some changes, right? So some tweaking may be required, but we don't want to call that out as explicit requirements here.
Mm-hmm. So actually, this sentence here, right? The kernel handles the errors and events based on the notification and logging mechanism. Based on industry standards. I think this is where even the CPER or VIA, like all of that is included, right? Because if you're
and reports to upper layers, and reports and further propagates to upper layer of the software stack.
Okay, sure, yeah, that's
and IA, IMA, right? IA like a RAS plugin, IMA.
Yeah, I think that completes it.
Yeah, this is good enough. Yeah.
Similarly, device drivers expose the error data to the IMA in a standardized format, hence satisfying the requirement of software scalability for the hyperscaler infrastructure. So this is where, again, starting from here, right?
Yeah, we're not calling any standardization here also, right? I think we just want to call out that the device drivers expose the error data to the IMA. Now, how it does it is not part of the spec.
But we are saying, right, it is going to be our in-band requirement is that we want to standardize this so that IMA gets it in.
Yes. So that is required. Okay, got it. Sorry, my bad. You're right.
It's kind of like following the right side and the left side, right? So I'm just
then don't call similarly then, right? Because the two things are not same, right? So device drivers expose,
So we can just do device drivers. Yeah, that's fine.
Yeah. Okay. Good.
All right, and examples. Okay, the in-band driver also provides a path for RAS actions. This one was, let's see. Examples of RAS drivers. The in-band RAS driver. I think maybe there's.
You mean RAS plugins, right? In-band RAS plugins.
Yeah. The RAS API actually. So RAS. Why is it in-band driver? Sorry, I added this before, but I would say the RAS driver also provides path for RAS actions.
Yeah, no, context is correct, right? I think what you're referring here is what now we are calling RAS plugins or in-band RAS plugins, or RAS plugins in-band, right? Which you are already describing in the next, other. Or this is just a summary. Okay, yeah. So this is okay, yeah. Yeah. instead of calling it invent RAS driver, just call that RAS plugins in the bracket invent, the way you have described.
Mm-hmm. Okay. I'm just gonna accept these. I'll move back to the editing mode. And the examples of RAS drivers or plugins are RAS daemon, EDAC driver, or a RAS API driver. So this is something that we can, whenever it comes along, we have those existing examples as well as future examples. And then this is the new content. So here's the description of the key blocks. And thanks, Sunil, for adding, initiating that. I plan to do that before the meeting. So I picked some of these, but let's review them. So I left this as is. So this is your description. In-band management agent is a software service located at the head node or the host or simply the main CPU subsystem, which is fine. And the purpose of IMA is to provide an interface between the hyperscalers management infrastructure and the platform used in the data center. IMA is expected to be developed by hyperscalers and maintained by the same without any requirements to make it publicly available. So is this accurate? The IMA is expected to be developed by hyperscalers.
Yeah, that is my language. If
should we be so prescriptive? That is my
if
question.
we can take it out. I mean, I don't think this adding anything from a requirement point of view, right? It just I was speaking loudly in my mind.
Any other objections?
Expected to develop by hyperscalers. Actually, let's just stop there. I may expected to be developed by hyperscalers and leave it there, right? The rest everything can be deleted. It's basically calling like I may own by hyperscaler,
this
right?
part, right?
Yeah, then delete that.
Yeah, I think that part could certainly be removed.
Hey, IMA expects to interface with the rest of the platform using standard API. That's the goal. Okay, RAS plugins.
There's a comment from John. Aren't plugins user space code? Yes, that's correct.
Not necessary, right?
No, they are.
Plugins are supposed to be the communication channel. So here is what I added here. Let's go through this, right? So in-band RAS plugins are software modules that execute at the kernel level and may be integrated as part of the operating system and are located at the head node. I would consider IMA to be as a user space code, but RAS plugins, because it is inherently like part of the communication channel below.
No,
right?
actually, so at least in our domain, right, we want the kernel to be as thin as possible. Okay, and any kind of this plugin, right? We don't like to have unless it's absolutely necessary. Like sysfs, for example, is not very interesting because sysfs is unfortunately delivered as a part of kernel and has all kind of challenges. So we'd like to see the plugin, and this is again I'm relaying what my kernel experts in Meta tells me all the time, and John probably can.
So let's look at this, right? So RAS plugin, which is exposing the RAS API, and one example of it is either using, say, CCI interface, or we are talking about even ACPI, right? So in that case, you're still talking about kernel level code, right? Which is going to it's basically a communication channel to the lower layer, right? So
Right.
so this is the one which
yeah.
added
So RAS
here.
plugin will be upstreamed, right? Expected to be upstream, and we will pull it out from there, but not delivered as a part of the kernel. What do you call kernel code? Kernel code and the plugins are two separate things.
Correct. It's like a kernel module, like kernel level, but not really.
So the two examples given in the previous paragraph for RAS plugins are EDAC driver and RAS daemon. EDAC driver is part of the kernel, RAS daemon is not.
And that's where the EDEC was the one where we kind of run into challenges, right?
Right.
Because,
so, I mean, what I'm trying to say is even the examples kind of suggest that, it's not necessary, the RAS plugins are not necessarily part of the kernel. It's a unit that's tightly coupled with the kernel, because.
Right, and we're trying to avoid that. We are trying to minimize this. EDEC actually is a very classic example, which causes a lot of challenges, because it is tied to the kernel, but at the same time, so if we modify kernel, then we need to sometimes EDEC driver breaks, right? So we need to make sure that EDEC driver is being supported correctly with every kernel version. At the same time, if the platform changes, then also EDEC driver changes. So maintaining the EDEC driver compatibility with the kernel versions and the platform is so challenging. So we want to decouple that. And that's where this RAS daemon or the user space code concept is so attractive to us. So that it decouples from kernel.
Right. And so John's comment about it being user space sounds like, that's where we should be. I mean, we shouldn't be calling it kernel code.
Yes, we should not be. Yes.
Yeah, but I mean, I agree with your verbiage regarding tightly coupled with kernel, because it could be at that level, right? So even if you're using that, the goal here is that RAS plugin is only a conduit to providing an API. It could purely be a software module, which is like hiding all of the platform specific or kernel specific behavior, right? So, but it could be tightly coupled with. It has to couple with the lower level.
So let me add a little bit more context to why I originally had that comment. So just for a little bit of background, I'm mostly coming from the software kernel like lower level like user space software frameworks type of background. So a lot of the hardware things may go over my head. I'm learning. I'm trying my best. But it stood out to me for the same reason why that Mita brought up. Just when someone says, at least to me, a kernel guy, or these plugins are executing at the kernel level, and then you say kernel module. Typically, the verbiage for kernel module means that it is running in that sort of privileged kernel code section rather than in user space with in a much more sandboxed environment. So I think I get your point, but it was more of the verbiage, at least to me, was a little bit confusing.
Mm-hmm.
So do we really need to define how it is implemented? We need to focus on the functionality that needs to provide. It could be all of the above, really. We should leave it at that. Why being so prescriptive about how it should be implemented?
Right. Actually, the language could be improved to remove like where exactly it is executing, and we can restrict it to what it is providing, right? What its purpose is. So I think, okay, I'll take a stab at like removing this and making it generic. It's
Yeah, the second
the next
sentence is
sentence
correct.
is more. Yeah.
Yeah, so you can delete that first sentence. By the way, I might have written that, so I apologize creating this mess here. You can delete the first sentence, by the way, because your second sentence is more appropriate.
Right. Yeah. So I removed your previous one and then I added that the purpose of these plugins is to provide communication channel for the RAS API towards the IMA on one side and then existing kernel or hardware on the other side.
Yes.
So that's okay.
Yeah, that's the perfect sentence. Yeah, way to communicate that. Yeah.
Okay. So I will remove your original sentence from here. Right.
Yeah. And even the first one, right? Let's get rid of the first one. Yeah.
I can also do it like this, right? Whose purpose is to provide
Yeah, that's fine.
okay. And there could be more than one plugins depending on the implementation choice. So this, you had added that, that's fine. Choices. And then RAS plugins may contain platform-specific modules and are accessible to the hyperscalers using industry standard methods such as GitHub. Yes.
By the way, this was my understanding, John, or anybody else, please chime in if this is not how, because I'm not expert
I added one more thing to that just to make it more generic. I didn't remove your sentence, but I added one more saying that it is also possible to have a vendor specific plugin because I mean, even if it is, we talked about this extensively last time, right? We last mentioned that it could be vendor specific and then further discussion concluded
means
with
vendor
this.
specific, right? Platform specific implies vendor specific, right?
Oh yeah, it would imply.
I think the context here is that whatever the whosoever develops it, right, need to be available in an open environment to be consumed.
So then just call it open source because the GitHub part threw me off a little. Like I didn't quite understand. I think I do now. So
yeah. So I'm this is where I'm not the expert here. So open source has a different connotation, and I think vendors platform specific module may not be possible to open source all the time. Yet we still can consume it through some GitHub repository as a binary module. So I don't know how to call
I mean,
that.
GitHub is just source code control. So to me, it seems incongruous to just even mention it here.
Yeah, so let's keep it not even called GitHub. I just plugins may contain standardized or platform-specific modules and are accessible to the hyperscaler using. Yeah, method. That's it. Don't say GitHub. Yeah.
Well, can't we just end with the word hyperscalers there? I mean, it doesn't have to be using industry. It has to be accessible to the hyperscalers, and hyperscalers can debate that with whoever's providing it.
Yeah, that's fine. Yeah, that's good enough.
So I'm just
saying, what did you say? Remove it?
No, just end with the word hyperscalers. Hyperscalers, period.
Yeah, okay. Yeah, that makes sense. I mean, we don't have to mention how they get it.
We'll sort it out, I promise. Yeah.
No, but one of the things is though, like say we write a plugin, right? And we align on certain plugins. They should be easily available, right? Like today, when you write a EDAC driver, it is available in Linux kernel, right?
Easily accessible. Call it easily accessible driver.
Well, I mean,
that's very vague.
Why though? I mean, like, some company may decide that they want like their own like rolled out version of something like an EDAC driver, and that's also okay, right? I'm actually not quite clear why we are.
For hyperscalers, we prefer not to make it to implementations or proprietary only. Enterprise, yes, possible, because there is always some proprietyness concept. But in hyperscale, I don't see that unless you're familiar with, like in your domain, right? Do you prefer
Well,
to be
but
proprietary?
I mean, I could see someone saying, I have a proprietary RAS plugin, I'm giving you the source for it, and we're fine with that, right? So,
Yeah.
Right, yeah, I agree with that. Because say, you're on a path to standardization, you were not able to make it, it is going to be proprietary for a phase, right? I'm just thinking from a
Just the API that we want to be standardized, right?
exactly. The plumbing is not proprietary. The plumbing is standard. Exactly.
Right.
Okay. So we can move on. It is highly recommended to ensure backward compatibility of the RAS plugins to ease the adoption of the new capabilities without disrupting the existing systems already deployed. I did not, I'm not sure I understood this sentence, Anil, or the backward compatibility reference.
Yeah, so backward compatibility concept is that when a new plugin is delivered, and let's say it has been tested with kernel XYZ, it's a 1.0, for example, okay? But I'm using 0.9, right? Sorry, to ensure backward compatibility of the RAS plugin to ease the adoption of new capability without disrupting. Yeah, so if
So this is more like generic, are you saying like generally, like any software that you're providing, make sure that it is backward compatible?
yeah, so like a Linux lingo, right? Whenever there's before they release a new kernel version, there are a bunch of patches, and they make sure those patches are all working on the previous version of the kernel, right? So that and sometimes even backward portability is done, so that those patches are tested on the previous version. And a hyperscaler may choose not to even upgrade the kernel, right? But still want the capabilities, new capabilities. So that's the context I'm trying to put here. I don't know, maybe I did not call it out correctly. If this is not something that important, we can take it out for now.
That's developed by the hyperscaler only, right? So it's really up to them. Right.
Second,
so we're saying that these are developed by the hyperscaler, right?
No, plugins are not.
No, plugins are not.
Oh, only IMAs.
Oh yeah, because this is, I don't see that it adds value, and in fact, if this recommendation, I mean, do we have to really stick to it? Because
I mean, the thought process here is
regeneration you may have, like when proprietary code that is different, right? And it may not.
So let me kind of clarify thought process, right? Let's say I have a system today, right? And a vendor says, hey, I have a new plugin and I've tested it, works fine. It has such a cool feature. We say, oh, great, we can use it. But then, oh, by the way, it'll work only with 6.9 kernel. And so, oh, we don't have that. We are still operating at a 5.9 or 5.1, right? So it defeats the purpose, right? So we are trying to, that's what I was trying to communicate, that the plugins should be backward compatible with the previous generation of the kernel, something like that. I don't know. Actually, remove this one for now, because maybe this is getting too much into the implementation kind of detail. I don't think it's relevant here.
Any objection? Everyone agrees to that? Or, I mean, I get Anil's point.
It gets into implementation, right? From a requirement spec point of view, it's a very standard norm, so we don't have to specify.
Everyone okay?
This is Charlie from Cisco. I have one comment. It's possible that some plugins might not be backward compatible. So, I think we would want wording to say something to the effect of plugins should be backwards compatible, but it's not necessarily a requirement.
Yeah, that's the challenge, right? Whenever it is not, then it becomes a problem for us to consume. And how do you, which is a true statement, as you said, right? I mean, so now the question is, how do we put this in the requirement? We can't, right? Because the fact of the matter is, it's going to happen. So, yeah.
Yeah, so do we put it as a note, as a footnote or something like that? So it's not a requirement, but it's something to think about that otherwise someone reading the document might not think about.
Yeah.
So we can just, if we want to just we can just say that it is recommended to ensure backward compatibility.
But it's not a hard requirement.
But
not a strict requirement or hard requirement.
Mm-hmm. Okay, then we don't lose that point either. Okay, RAS API. So I added some content here. RAS API is defined as part of the separate OCP workstream and offers standard way to interact with platforms, to collect error logs, to initiate RAS actions, and to monitor RAS actions taken autonomously by platform. So this is your sentence, Anil, and it's good as is, at least from my perspective. And I added here that the API prescribes the standardization of the content and action commands that are exposed via RAS interface. And RAS plugins prescribe how the communication channel could enable the RAS API. So it just like connected these two, that how they are related, that the API will prescribe the what, right? The content and the action commands, and the RAS plugins prescribe how the communication channel enables the API. So it's clear that RAS plugins are enabling the API, but not necessarily impacting what flows on it. Right?
There's a comment from Dean. Which of the components in this section are expected to implement the RAS API?
Oh, where is that? Okay, so which to implement the RAS API? So RAS plugin is one part of it, right? It is the one which is exposing it to the IMA, right? But everything below that could contribute towards it, right? The expectation is that this interface is providing you with communication channel for getting standardized data, but
so the
any of these could be contributing to it.
Yeah, the way I'm thinking here, responding to Dean's point, right? The implementation of RAS API is going to be implementation specific, and it may be split into multiple sections depending upon the platform capabilities. The interface to the in-band agent is standard. That is provided by these APIs. So RAS API is the API spec. The actual implementation is platform specific.
So I mean, should I just add a comment to respond?
Yeah. So actual implementation of the RAS APIs is platform dependent. No, I mean, yeah, responding there, but I think we should add the sentence here.
Oh, what did you say? Oh, sorry, I missed that.
the implementation
Mhm.
of the RAS API will be is expected to be platform specific.
Oh, or rather the components, so we can just write it in the answer format.
If I'm
right?
to guess, I think Dean's question may be just asking what's on each side of the, RAS API. And in your figure, that just seems to be in-band management agent is one side which implements the API, and the other side is either the vendor code or the RAS plugin. And I think that's maybe what he was asking for, getting written down in words.
Yeah, so
Just-
embedded agent will consume the API, or rather I would say will write things based on the APIs. And the implementation will be somewhere in maybe partly plugin, maybe full in plugin, or maybe part of the firmware, some part maybe in a hardware.
No, but if you look at this diagram, right? So his question is like, which components are participating in this, right? Like which components in this section are expected to implement the RAS API?
Correct.
So like, is it the RAS plugin? Is it the kernel? Is it like which one of these components are implementing? And so the answer to that is that it could be anything. I mean, you need the RAS plugin for sure, but at the lower layer, it could be firmware kernel that is contributing towards the implementation of the RAS API, right? So
And we're trying to minimize the kernel changes. So preferably plugins and firmware and some part maybe low-level hardware.
yeah, but we can't prescribe that, right? So we can say RAS plugin, and beyond that, it is going to be implementation specific, right?
Mm-hmm. Yeah.
So oops.
And rest of the platform implements.
Okay. I don't like how I phrased this, but it's basically below that, it's all implementation specific. Okay, I can wordsmith it a little bit later, but
Yeah.
I think we all agree with the idea, right? That it's going to be implementation specific. We do need plugin, but below that, it could be any of those components.
Yep.
Just I'll do this. Kernel, we're almost at the top of the hour. So kernel is part of the software stack that provides a standard way to interface with the CPU subsystem. This is okay. It includes RAS-related modules and handlers for architectural and standardized error reporting mechanisms such as MCA, AER, and APER. So this is something that we just discussed in the overall description. Any objections here? I added this thinking that we have these, we have AER handlers, MCA handlers, and so on, which are either architectural or like standardized mechanisms that are part of the kernel implemented today. Right? And the OS kernel may contain an in-band error logging agent, which may also be able to trigger RAS actions on the node it runs on. So this is Anil I think it's okay. It makes sense that you're mentioning that there is an agent which could trigger RAS actions like something like a so anybody any objections here, or it's all good?
When you say OS and kernel and in the same like the OS kernel, to me it's a little bit confusing. Kernel is
Oh, was
kernel,
it?
and then OS is on top of OS is some additional modules together, right?
Yes, yes. This was it already there? This is, we can just do the kernel may contain in-band error logging. The OS is a little bit up, like, you know, something like PFA algorithm. That's what I visualize when when I saw this sentence. So if you want to trigger any actions, you may be using something that consumes the error data and then takes some action, right?
I see.
So
I see.
that,
So then call it operating system because it actually sits in the user space, some part of the user space, like in the page offline flow, right? I think I may be wrong here, but some part is in actually user space.
right.
But it does interact with the kernel.
So I mean the OS or do we want to call it both? Because I mean we don't.
Yeah, that's okay. OS / kernel is okay. Yeah, that's okay. Yeah.
Okay. The next one is CPU, memory, and HSIO devices. So this was Anil, I just restructured this a little bit. We have all the hardware layer at the bottom. So just a very simple description of that CPU, memory, and HSIO devices are part of the CPU node hardware. And we don't need to talk more about it, right?
What is HSIO?
Oh, I don't know, someone, it was HSIO devices, high-speed IO devices, right? So
yeah, just spell it out then. I don't remember changing that.
I think, yeah, so this was changed. I think we did it last time.
No, Anil, I asked that question. I did not think I changed that. I asked the question whether it's high-speed IO devices or it's just any devices, which could be your sideband devices also. But I don't remember changing the diagram.
Spell it out.
Now,
another question I have on the diagram. Actually, we are a couple of minutes above, but I think on memory. Oh, maybe I did make the change. Sorry. I should. I did work it right. So memory, we mean direct attached memory only here on the platform, or
no, it doesn't have to be. Yeah, I noticed that these two blocks changed, but I thought we had already done that together. But it doesn't have to be direct attached, right? It can be CXL, for example.
No. So CXL is a HSIO device.
It is, yeah.
Okay.
That's why the
distinction is right. But then the direct attached memory is what it says, like attached to CPU, which is essential. I don't know if any system that is implemented without any direct attached memory.
Sure. Yeah.
Right.
Yeah, I think we are distinction. The distinction is memory controller on the CPU itself and on HSIO attached device. That's the distinction there.
Right.
And that will have
from error handling point of view also, right? The CXL memory handler is sort of CXL driver, right? It doesn't go through the kernel.
Right.
Okay. So do we want to just turn this into IO devices, or HSIO is fine?
Yeah, that's okay. That's fine.
Okay.
I just need to know what that means.
So the next one was, should we continue next time, or like how does everybody feel just finishing this off?
Since we are at it, let's finish it.
Okay, so it's pretty straightforward. It was firmware components initialize the platform. I removed this and to operate the services hosted. I think there was like some little bit of a. I combined it. I took it from here and put it here, but it basically initializes the platform, and during runtime, firmware may perform low-level system management tasks while OS is running, such as error handling, power management, and vendor-designed code. Firmware first mode of error handling is handled by this layer. So we mentioned firmware first multiple places, so I added that also just to make it clear. And it's in both parts, right? It's in,
Maybe we should pick it up on this point, page 14, top of page 14 next time.
Okay.
Seems like
Yeah, let's call it.
better idea. All right.
yeah, this
So
one is
see you all
complete.
in, yeah, see you all in 2 weeks. Then next week I already sent the cancellation of the meeting.
Yeah, and Shubhada, really appreciate driving this. Maybe we should put some time together to scrub further the remaining section, and before we come back and have it reviewed here, so that
Yes.
next time we can finish more.
Yeah, I had a suggestion. If we already talked about it, if we can just clean out and remove this out of band section, right? There are good suggestions here. Maybe like keep it concise, and because I added a line here to make it out of scope, but it is only mentioned for sake of complete.
And eventually we want to merge them, right?
Yes.
Right.
Yes,
so
exactly.
we would have that content anyway on the other side, right? So
Yeah.
You're absolutely right. Yeah. So we can, at least from this document, we can delete it because it will be merged anyway.
Okay. All right.
Very
Have
good.
a good
Thank you.
weekend, everyone.
Hey, John,
good.
real quick, John, sorry, your email address is just your last name without any dash at Google, right?
It's I think it's PANDOH at Google is what I think it
Okay.
is.
Yeah, okay, I found my mistake. Thank you, Drew.
You're welcome. And I wasn't trying to talk for John, but yeah, anyway.
Hey, Drew, if you have a couple of minutes, I just want to talk, brainstorm a little bit thing with you, if you have a few minutes.
Sure. How do you want to do it? Do you want to just stay here?
Yeah, that's okay. Basically, in this section, in this document now, right, as Shubhada was mentioning, the remaining part of the document is pretty much copy paste from the existing out of band flow, right? Although there are some sections here which has in-band also, but I don't think we are changing that because I think you did a good job in documenting that. So I was just thinking that from the in-band edition, I think what we did so far is pretty much sufficient unless we need to make some more changes. Maybe we are in a state where we need to start merging the two. What do you think?
I'm good with that. I mean, how do you want to do it? Do you want to take a pass at it? Do you want me to try to take a look at it? What works? It sounds good.
Okay, let me try, and then I will put some time. Shubhada, if you are interested, then maybe three of us we can meet together next week. And
has left the call, Anil.
Anybody else interested to participate in merging the two?
Yeah, just send me the invite too.
Okay, cool. So three of us will converge. We'll talk next week before Friday anyways also. Even next week Friday we can. No, but you said Friday you want to keep it open, right?
Cancel the meeting, but yeah, if you want to set it up before that or whatever time Drew works for you. I don't want to drag people late into the beginning of the long weekend. So, you know.
Yeah, that sounds good. So Neil, let me. I think you're going to be the gating factor because you're going to take the first pass. So, when you're done, ping us and we'll find a time to talk.
Awesome. Sounds good. Thank you.
Sounds good. Okay, talk to you then.
Yeah, bye.
Good one,
See you.
guys.
Anil, if you could send me also.
Okay, so cool. I will do that. Yeah.
Anji,
Yeah.
thank you.
Thank you.
Great. Hey, Drew,